You are on a rescue mission in the Gulf of Suez. Your ship is steaming east when its sonar detects the disabled submarine 5 nautical miles away at an angle of 30 degrees to the south of the eastwardly path. The submarine can transmit distress signals that can be detected at a 3-mile radius. If the ship hadn't detected the submarine, how far would it have to go on its eastwardly path before the distress signals would have reached it? This information creates an SSA triangle, 3 miles, 5 miles, and 30 degrees. This is an example of the ambiguous case. This criteria can create 2 triangles. Both of which would have the 3-mile side. 1 triangle, 2 triangles. Let's label the sides as A, B, and C, with an uppercase A, B, and C for the corresponding angles. To find the potential lengths for side B, we use the law of cosines. A squared equals B squared plus C squared minus 2BC times cosine A. Plug in the known values for lengths A and C, as well as angle A. This solves to a quadratic, which we can plug into the quadratic formula. B equals 2.672, or B equals 5.988. Between these 2 points, the submarine's distress signals would reach the ship because it is within the 3-mile radius, as seen here. For the following problems, we will consider B to be the further length the distress signals could reach, the larger of the 2 triangles. So B will be equal to 5.988. We will find the measure of the angle B between the ship's initial position and the farthest point at which the distress signals could be detected. We will use the law of sines to solve for angle B because we know the length of the side A and angle A, as well as the length of side B. Plug in the values and solve for angle B. Angle B is equal to 86.442 degrees. Now we want to find the area of this triangle. Because we know the length of all the sides, we can use Hero's formula. Square root of S times S minus side A is S minus side B times S minus side B. S is equal to 1/2 of the perimeter. Plug in the values. S is equal to 6.994. Plug this into Hero's formula and solve. The area of the triangle is 7.486 miles squared. The submarine also carries short-range radio transmitters that will transmit radio signals only 1 mile. Was our ship ever within reach of these signals while traveling on its course? To find out, we must look at the shortest distance between the submarine and the ship's path, which would be the line perpendicular to the ship's path, forming a right angle. Now let's look at the bigger of the 2 right triangles formed by the 90-degree angle. Using the tangent formula, which is opposite over adjacent, we can find the length of this side, which we will refer to as x. Plug in your values and solve. X is equal to 2.887. This means that the shortest length between the submarine and the path of the ship is 2.887 miles long, longer than the 1 mile radius of the sub's radio signals. Hence, the sub's radio signals would have never reached the ship.
Number 33. Write the Charlie.